Hi, welcome to pre-calculus. Topic today is sum and difference identities problem type 4. So type 4 here means that the input values are given in terms of variables, u and v, or some pair of letters here, and we have combinations such as what you see here: sine of the quantity, cosine inverse of u minus tangent inverse of v. To make the problem simple and manageable, the assumption is that u and v are positive numbers. Therefore, the angles we are involved with are all in the first quadrant. So this problem, like the previous one, revolves around a review of some older problems combined with sum and difference identities. Let's just remind ourselves what is the applicable identity here. I have difference of two angles here, so I remind myself the sine of alpha minus beta, and that is sine of alpha cosine of beta minus cosine of alpha sine of beta. Okay, so we are going to set this one to be our alpha, and this one is going to be our beta. So alpha is cosine inverse of u, and beta is a tangent inverse of v. Perhaps best approach here is to draw a quick picture. When we say alpha is cosine inverse of u, what does it mean? It means u is cosine of alpha. What's the picture that comes in our mind in relationship to this? We have a right triangle, angle here is alpha, cosine of it is u. Well, cosine is the ratio of adjacent, here's adjacent to hypotenuse. We might take the adjacent to be u and hypotenuse to be 1. Well, what's going to be left for the other side? Apply the Pythagorean theorem to find out that this is 1 minus u squared. Well, I have cosine of alpha, which I'm going to need here, but I also need sine of alpha. So I'll go ahead and write, so cosine of alpha, I know it's just u. Sine of alpha in this picture, obviously, ratio of the opposite, here's opposite to hypotenuse, is 1 minus u squared. Let's go after this one. This one means v is tangent of beta. The picture that goes with this thing, we have v, here's angle beta. Tangent of it is ratio of the opposite to adjacent. In this case, the hypotenuse by Pythagorean theorem is 1 plus v squared in square root. What do we want out of this? For beta, we want cosine and sine. So cosine of beta is a ratio of adjacent to hypotenuse, and then we have also sine of beta, and the ratio of opposite is v. Yeah, hypotenuse is again 1 plus v squared in square root. Now we just plant all of these in our expression. Sine of alpha is this creature here, 1 minus u squared. Cosine of beta, I hope my handwriting is clear that this is 1 plus v. Let me write it bigger. Cosine of alpha is going to be, so minus, cosine of alpha is u, cosine of alpha is just u, sine of beta is v, so this is v over same expression, 1 plus v squared. So we might as well take a common denominator as 1 plus v squared. Numerator is radical 1 minus u squared, and this one is just minus uv. That is the answer to this problem. Just a practice on a combination of several ideas we had. Here is another one similar to what we had, same setting, except this is cosine, and let's just go ahead and call this thing alpha and this thing beta. So what we need, cosine of alpha minus beta, is the identity for the cosine of difference. We are going to use that plus, remember, sine of alpha, sine of beta. We go draw some pictures. So alpha is cosine inverse of u, so that means u is cosine of alpha. We have a picture goes with this, a right triangle, this is an angle, cosine of it, ratio of adjacent to hypotenuse. I take the hypotenuse to be 1. I'm going to take it anything, which just take it to be 1. Opposite by Pythagorean. So let's write cosine of alpha is, as we said, is just u. Sine of alpha, we are going to need radical 1 minus u squared. Let's repeat all of this for beta. So beta is sine inverse of v. So that means v is sine of beta. The picture that goes with this, a right triangle, angle is beta. Sine of it is v. Well, as the opposite is v, and the adjacent now becomes 1 minus v squared. Let's repeat. Sine of beta is v. Cosine of beta is radical of 1 minus v squared. So we're done with that. Biggest challenge here is to make sure your v's and v's don't look like each other. Then cosine of alpha, here is cosine of alpha we need. Cosine of beta, radical 1 minus v squared, plus sine of alpha, radical 1 minus u squared, sine of beta, which is v. Here's a v, and there isn't much that we can do to this to simplify anything. So that's the final answer. Again, just a practice on applying various trig identities and topics we had before. So until next time, good luck and God bless.